We are going to talk about weight percent units that, as we said before, it may not be the most important one, but you will see it quite often. Uh, the, the, the most common is the weight percent, in which you just do the ratio of mass over mass of solution and multiply it by 100. So just probably the best way to understand this magnitude is by solving an example. Let's read it all together. So the maximum concentration of arsenic in drinking water that is allowed by the Environment Protection Agency is 0.050 milligrams per liter. Express this as a weight percent. Notice that this unit is what we call density. It's mass over volume, and we need to express it as weight percent. An important note is that you can assume the density of the water solution, not the water. So, well, two things. Sure, density of water is 1 gram per milliliter, but what's saying here is the density of the solution is also around 1 gram per milliliter. How could that be? If the solution has the solute in it, it should change the density. But notice that we have a very tiny amount of solute, so the density of the solute and the density of the solution will be very similar. Anyhow, so let's see, first of all, to convert this magnitude into weight percent, we need to choose one unit of mass. So let's say that since the solute is already milligrams, we can convert liters of solution into milligrams. So this will be 0.050 milligrams of arsenic divided by how many milligrams is 1 liter? I know that 1 liter, so again, one liter is 10 to the 3 milliliters, and the density says that in 1 milliliter I have 1 gram. I'm just now one step away. 1 gram is 10 to the 3 milligrams. Okay, so this is, if you did it well, it's 10 to the 6 milligrams. Okay, so 10 to the 6 milligrams of solution, not solvent, solution, and I multiply this by 100. Okay, that will be the weight percent of arsenic that EPA allows to have in water. Okay, also a very common weight percent, because as you can imagine, this fraction will be fairly small. Let me see if I can do it. This will be 5 to the negative 2 times to the 2 divided by 10 to the 6. Okay, well, this means that it's 5 to 10 to the negative 6. So that's a tiny number. So sometimes what we will work on is parts per million. So instead of multiplying by 100, we will be multiplying it by 1 million, so that we don't deal with these small numbers. So let's just see if we can solve this problem. Say, suppose you have 155.3 grams sample of a pond water that is found to have this many grams of phosphate. What is the concentration of phosphates in ppm? Again, so ppm, it's the parts per million. So how much solid do we have? 1.7 10 to the negative 4 grams. As I said, it's important that we have the same unit on the numerator and denominator. So this will be of solute, and the solution, we have 155.3 grams of solution, and we'll multiply this by 1 million. This will be the ppm. That is, if you notice, this will be a more reasonable number, not as small as the previous 10 to the negative 6. One step farther is the ppb's, parts per billion. As you notice, many of these problems are environment related, because the threshold of environmentally dangerous compounds are expressed in tiny concentrations. We will use ppms and ppbs, but it's very, very important that you can use both in the numerator and denominator, the same unit, and then multiply by whatever number is. Weight percent is 100, the ppm is 1 million, and the ppb is 10 to the 9 billion.